let's take a look at negating quantifiers. So what happens if I want to negate a quantifier? Let's see if we can take a look at negating the universal quantifier. And we're going to go back to the definition dealing with conjunction and disjunction of propositions, which we've already seen, and then we know how to apply De Morgan's laws to negate it. So let's just assume our set contains x1, x2, all the way up to some xn. And I haven't specified how many elements that is, so we're safe there. Then if I want to write out another way of writing out this is to say I have the negation of q of x1, and this is for all, so I need them all to be true for it to meet this criteria. So and q of x2 and all the way out to q of xn. Okay, but now I have that negation. And we know from De Morgan's laws that if I negate across conjunction, what happens is I actually get the negation of the first one, and I take and flip that to be or instead of and so I move it from conjunction to disjunction, but then I keep that negative. The negative of q of x2 or the negative of q of xn, all with that or between, using disjunction. But now what I see is that I've got the equivalent of there exists an x in our set S such that we have the negative of our predicate q of x. And so that returns us to where we wanted to get, and that is that the negation of for all x and s, q of x is true, is equivalent to saying that there exists an element such that q of x is false, or that the negative of q of x is true. So the way that we obtain a false value for all x, q of x, is we find at least one x that doesn't meet that criteria. And what about negating the existential quantifier? We can do the same. So just as before, we can say that the negative of there exists an x such that p of x is true is the same as saying we want to negate the fact that p of x1 is true, or p of x2 is true, or p of xn is true, where x1 to xn are the elements of that set. And we know from De Morgan's laws we can also bring that negative throughout and flip the disjunction to conjunction, or the or to the and this becomes negative p of x1 and negative p of x2 and negative p of xn. And this is the same as for all x in our set, p of x is false, or not p of x. And I think this is also important when we start talking about how we show that there exists an x such that p of x holds is not true. And we do that by finding that we look through all the elements in the set, and we say, you know, it doesn't hold for any of those elements in this set.